Welcome everybody to Euclid's proposition number 31. In this proposition, what we're asked to show is that if we are given a line and we're given a point that's not on that line, we are able to construct with compass and straight edge a line that will be parallel to the given line that also passes through the point A. Let's take a look and see why this is going to be true. What we want to do first is to just choose an arbitrary point somewhere between our points B and C. So let's just choose point D that happens to be right there. Now what we want to do is to draw the line from D to A. And we are able to do that from our postulate number 1, which says that between any two points there is going to be a unique straight line. Now from our definition of a circle, we're able to draw the circle centered at D and passing through A. Now this circle is going to intersect our line BC at, say, point E. Now also from our definition of a circle, we are able to draw the circle centered at A and passing through D. Now this circle is going to give us another intersection point on our line DA out here at point F. Now what we have from definition 16 is that our line segment DA is going to be congruent to our line segment DE. But then also our line segment AF is also going to be congruent to both DA and DE. Now to remove some of the clutter for just a little bit, let's take away our first circle centered at D. Now if we consider the line from F passing through D, or that ray passing from F through D, then proposition 2 tells us that we are able to construct a point G on that line so that our line segment FG is going to be congruent to our line segment AE. Now if we draw the point centered at F and passing through G, what we find is that we have another intersection point, H, with our circle centered at A and passing through D. Now what this means is that our line segment FH is going to be congruent to our line segment AE. And also because H is on the circle centered at A and passing through F and D, it means that our line segment from A to H is going to be congruent to our line segment from A to F and congruent to our line segment from A to D. Now if we go in and remove our circles, what we find here is that we have two triangles, FAH and triangle ADE, for which we have two sides that are going to be congruent, and we have the third sides that are also going to be congruent. And so those triangles are going to be congruent by our side, side, side triangle congruence, which was proposition 8. Now in particular what that means is that our angle HAF and our angle EDA are going to be congruent. And if we have GeoGebra measure those, we see that sure enough, in fact, they are going to be congruent. If we now draw the line AH, and let's remove a couple of those line segments, what we find is that we have corresponding angles that are going to be congruent for two lines which are cut by a transversal. Now what that means by proposition 28 is that our lines then must be parallel, as was to be demonstrated. I hope you guys enjoyed this video, and I will see you guys in the next one. Take care.